as we continue to move through Unit 7, the equations kind of get harder and harder as we go. In Unit 7, Part 3, we're talking about solving equations with variables on both sides. So again, this will be a little bit more difficult, so please make sure you take good notes. The first thing we're going to do is check possible solutions again before we actually worry about solving. So the directions say, tell whether the given value of the variable is a solution to the equation. So our first equation is 41 minus 8x equals negative 6x minus 23. And the solution that we're checking is x equals negative 9. So again, when we're checking solutions, that just means I'm going to plug in that solution for the variable. So I'm going to plug in negative 9 everywhere I see x. So I have 41, and then negative 8 times negative 9 is going to give me positive 72. And then I'm going to have positive 54 minus 23. So 41 plus 72 is going to give me 113. 54 minus 23 is going to give me 31. So this is not a solution because they don't work out to the same. I'll let you guys go ahead and do number 2 on that section. So scrolling down, now we're actually going to get into solving equations with variables on both sides. Now, before we were solving equations, we'd always go to the side of the variable and work from there. Now, again, the whole point is that there's variables on both sides, so we want to move it so that our variables are on one side and our constants are on the other. So, as always, I'm going to start by boxing and rewriting this. So I have 12x minus 28 equals negative 63 plus 7x. So for this problem, I'm going to show you a couple different ways you could do this. Okay, remember, I want variables on one side, constants on the other. So one way I could do it is to subtract 7x from both sides. Okay, when I do that, I wind up with 5x minus 28 equals negative 63, because those wash out. So the point of that was that I got the goal of getting all my variables on one side. The x's are all on the left. Now if I put all the x's on the left, that means that I need to add 28 to both sides so that all my constants wind up on the right. So on the left I just have 5x because those are a wash. And then on the right side, when I do negative 63 plus 28, I get negative 35. So then my last step to solve is just to divide both sides by 5. So I get x equals negative 7. So that's one way to do it. I subtracted 7x from both sides. Another way I could do it is I could start with one of the numbers. And I could say that I want to add 63 to both sides. When I do that, I get 12x, negative 28 plus 63 will give me positive 35 equals, those will wash out, 7x. Now if I were to do that, if you look, my constants are all on the left hand, because I have 35 over there, which means I would have to subtract 12x on both sides. I would have to move that over. Those will wash out, so I'll have 35 equals negative 5x. And my last step will be divided by negative 5. So I get negative 7 equals. So if you look, I did it 2 different ways but got the same answer. There's even more ways that you could do it. I could subtract 12x first, I could add 28 first. But the point is, you're going to wind up with the same answer no matter what. Now, I personally subtracted 7x first because I wanted to wind up with a positive 5x right here. Okay, but again, it doesn't matter which way you do it, you'll wind up with the same answer no matter what. Okay, if you scroll down and look, these are just going to get a little more complicated as we go through them. So I'm going to do number 3. Again, I start by boxing and rewriting. So 15x plus 24 equals 3 times the quantity 10 plus 3x minus 20. So the first thing I'm going to do is go ahead and do the distributive property. Again, I have a number out front of a binomial, so I'm going to distribute 8 times 10 is 80. 8 times 3x is 24x. 9 minus 2. Now, next thing I need to do is look and see that on the right side, I have like terms, so I need to put those together. So I'm going to rewrite the 15x plus 24. I haven't done anything with that yet. 80 minus 2 is 78 plus 24. So now I'm at the point where I have an x, a value of x, and a constant on both sides. So I need to move the x's to one side, the constants to the other. again, I'm going to choose to subtract 15x from both sides. The reason why I'm doing that is that I want to wind up with a positive coefficient, so that's positive 9x. If I had subtracted 24x from both sides, I would have wound up with a negative 9x, so I just don't want to do that. So that should be 78 right there, so 78 plus 9. Again, I could have subtracted 24x from both sides. I could have started by subtracting 24, subtracting 78, whatever. It doesn't matter what order you do it in, you'll still get the same answer. Now, since I chose to subtract 15x, that means I need to subtract 78 from both sides to get those constants over on the other side. When I subtract 78 from both sides, I'm going to get negative 54 equals 9x. And my last step is divide by 9. So I get negative 6 equals x. And I'm all done there. Alright, so 2 and 4 I'll leave for you guys. Remember, it doesn't matter which one you do first. If you want variables on one side, constants on the other. If you look at the back, please make sure you take really good notes on this, because this is pretty tricky stuff. We're talking about a couple special solutions. Okay. So, for the first one, again, I start by boxing and rewriting. Negative 6 times the quantity 4x plus 3 equals 6 times the quantity negative 4x minus 3. If you look, I need to do distributive property on both sides. So negative 6 times 4x is negative 24x. Negative 6 times 3 is negative 18. On the right side, 6 times negative 4x is negative 24x. 6 times negative 3 is minus 18. Now, if you stop right here and look, this equation is exactly the same on both sides. Negative 24x minus 18. When you know that's the case, we know that our answer is all numbers, or all solutions, however you want to say it. Okay? What that means is, no matter what number I plugged in for x, it would be a solution. So let me give you an example. Let's say that I plugged in, let's say I said x equals 2. So I plug that in on both sides for x. Okay, again, since they're the exact same thing, I'm going to wind up with the exact same solution on both sides. Now this would work no matter what I plug in, 0, 1, 2, 3, negative 5, negative a million, whatever. It'll work out for all of us. So that's an example of where all real numbers, or all numbers, are the solution. The next one, again, I'm going to start by boxing and rewriting. So I have negative 3 times the quantity 8x plus 11 equals 6 times the quantity negative 4x minus 14. So again, I need to distribute on both sides. So I'll get negative 24x minus 33 equals negative 24x minus negative 70. Minus 78. So if you look, both sides have negative 24x, but their constant parts are the same. So let's see what happens. I want to move the x's over, so I'm going to add 24x to both sides. But if you notice when I do that, those wash out. So I have negative 33 equals negative 78, which is not a true statement. So we call this no solution. So two special cases. One's all numbers. That's when it's exactly the same on both sides. No solution is when we work it out and we get two numbers that aren't actually equal to each other. So we know we're done there. All right, towards the bottom of this, we got a couple word problems here. So it says write the verbal sentence as an equation, then solve the equation. So our verbal sentence is 9 plus 2 times a number is equal to 2 less than 3 times a number. So remember, when we do plus means addition, and that means we can just write it straight as it is. So 9 plus 2 times a number is equal to, now it's less than, which is subtraction, which means we almost need to flip it. So that's 3 times the number, and then minus 2. Alright, so now we want to solve this. We have variables on both sides. I'm going to choose to subtract 2x. Again, the reason why I'm going to do that is because I want to wind up with a positive variable. So 3x minus 2x is positive 1x. Then since the variables are on the right, the numbers have to go to the left, so I add 2 to both sides. I get 11 equals x. Alright, this perimeter problem I'll leave for you, and you've got some review problems at the bottom, and that is it for Unit 7.